Good afternoon and welcome to this webinar on Big Data Security hosted by the Canadian Institute for Cybersecurity at the University of New Brunswick. This afternoon we have Dr. Suprio Ray. He's an assistant professor at the Faculty of Computer Science at UNB Fredericton, and he leads the Big Data Systems and Analytics Lab. Suprio is also associated with the IBM Center for Advanced Study Atlantic, and he regularly collaborates with researchers from other research institutes.
So as Mary-Jo mentioned, my research interests include big data and database management systems, scalable data science. What might be relevant to my research at CIC is privacy preserving data analytics. I'm also interested in parallel and distributed systems. So here's the outline of this short webinar. I'll be briefly talking about what it means to be big data. I'll be talking about some of the security challenges with big data. Then I'll mention pillars of data security. And finally, I'll present a landscape of big data security frameworks. As you might know, we are experiencing an explosive growth in the amount of data in the world. The amount of data generated is expected to double every 2 years. And by 2020, it is expected to be about 44 zettabytes. So this growth is due to various factors, but increasingly due to the volume and detail of information, the level at which data is captured by enterprises and other organizations. Also, increasingly, the rise of social media and other web-based applications are also contributing to this growth. And in the near future, the Internet of Things will also contribute significantly to this exponential growth. As I mentioned, so I'll briefly mention about the aspects of big data. So here we can see a landscape of the big data systems. And as you can see, it's a crowded space, and a number of big data systems have been proposed. So as you can see on the x-axis, or on the horizontal axis, you have DAG model, which are graph-based models. And then we have MapReduce models, and we have BSP, or bulk synchronized processes. On the vertical dimension, we have systems for iterations and learning, for query processing, and for streaming. So we'll mainly focus on this dimension, which is relating to the MapReduce model. So distributed programming frameworks, such as MapReduce models, utilize parallel computation and storage to process massive amounts of data. This framework originated when Google developed their Google file system. And the purpose of this was to create a distributed framework to process the indexed web pages. But it evolved and were adopted by the research community, industry, and academia. So in the MapReduce framework, the input file is split into multiple chunks. In the first phase of the MapReduce, a mapper for each chunk reads the data, performs some computation, and outputs a list of key value pairs. In the next phase, which is called reduce, the values belonging to each distinct key values are combined, and it outputs the result. So because we are restricting our discussion to particularly the systems that come under this model, we are considering what are the possible threats in terms of security and privacy. Particularly, there are two major attack prevention measures that are necessary. One of them is to secure the mappers and secure the data in the presence of an untrusted mapper. Next, I'm going to talk about the different challenges pertaining to big data. I mean, you may hear the word big data now, and it has become sort of a catchphrase, but enterprises have managed big data for quite a long time. But previously, big data was limited to very large organizations such as governments and large enterprises that could afford to create and own infrastructures necessary to host and mine the large amount of data. What is different now is that today, big data is cheaply and easily accessible to enterprises, large and small, through public infrastructures such as cloud. So the challenges today are multifarious. We categorize them into four different groups. So first one is infrastructure security. The second one is issues with data management. The third one is issues with data privacy. And the final one is integrity and reactive security. I'll be elaborating each of them next. So on infrastructure security, so this deals with the different kinds of infrastructure that are used to manage big data. For instance, a malfunctioning compute node in a MapReduce framework can cause a security breach. For instance, workers assigned to mappers in a distributed computation could malfunction due to an incorrect configuration. And a malfunctioning worker node could then return incorrect output from the mapper, which may compromise the integrity of the aggregated result. And such a worker may also be modified to leak users' confidential data or profile users' behavior or preferences for privacy mining, and none of them are desirable to anyone concerned in the security of a framework. Another issue could be infrastructure attacks. So compromised worker node. So a worker node is a node that performs the task delegated by it by the master node in a MapReduce framework. So a compromised worker node may tap the communication among other workers and master with the objective of maybe replay or some of the attacks such as man-in-the-middle attack or denial of service attacks to the MapReduce computation. Another sort of issue with big data frameworks is lacks authentication mechanism. So when I say big data frameworks, we tend to talk about this MapReduce framework that do batch processing, but also there are some systems such as Hive, Cassandra, and so on that are also used to do data analytics, but they provide more structured data storing mechanism, although they are not structured in the same way relational databases provide schema. So these kind of systems are known as NoSQL systems. So with regards to NoSQL systems, this lacks authentication mechanisms can be quite serious. For instance, this kind of mechanism can expose NoSQL to replay attack and password brute force attacks, which may result in information leakage. So NoSQL systems does not NoSQL does not support integrating third-party pluggable modules to enforce authentication. And so by manipulating the connection definition, it is possible to get access to the handle and configuration parameters of the underlying database. And this may allow someone to gain access to the file system. And the fourth one is susceptibility to injection attacks. So in an injection attack, could be an SQL injection or a JSON injection attack. For instance, an attacker can utilize schema injection to inject thousands of columns, imagine, so into the database with data of the attacker's choice. So the impact of such attack can range from a database with corrupted data to denial of service attack, resulting in total unavailability to the database, which is, of course, no one wants to happen. The next dimension is data management. So on this dimension, we are concerned with data and transaction logs that are stored in multi-tiered storage media. So as the data size grows, it necessitated auto-tiering of big data management systems, such as an example of auto-tiering is cloud. However, auto-tiered storage systems generate new vulnerabilities because of the lack of physical possession of the storage media. So previously, when proprietary organizations would manage the data, they would own the complete stack from the hardware and the software. But now with the cloud, this is no longer the case. So what are the issues that can happen? So one of the issues is the collusion attack, particularly when the service provider colludes with the users by exchanging the key and the data. They can obtain the data set that they are not entitled to. The next one is rollback attack. So in a multi-user environment, the service provider can launch rollback attacks on the user. Let's suppose an updated version of a data set has been uploaded, and the service provider can fool the users by delivering an outdated version of this this data set. So therefore, certain evidence is required to help users ensure that data is up to date, and the user should have the capability to detect this kind of inconsistency. One of the aspects of secure data management is data provenance. So provenance basically makes sure that the origin of data and history of data lineage is preserved. However, this also becomes natural target for big data applications. For instance, an outsider attacker can forge, modify, or unduly delay the provenance records during the transmission to destroy the usability of the provenance. And an insider attacker can even cause more harm because the insider attacker could modify and delete the stored provenance records and audit logs, and thus destroy the provenance system altogether. So the next dimension is privacy. When we talk about data privacy, it's also sometimes called, we talk about um, confidentiality and the privacy of the users. So big data actually can potentially enable invasions of privacy due to the fact that now marketing campaigns can use this kind of large volume of data. A recent analysis of how companies are leveraging data analytics for marketing include an example of how you may have heard that a retailer was able to identify a teen's pregnancy before her father actually learned from it. So by analyzing the purchasing behavior of that lady, the company was able to sort of determine that she was pregnant. So therefore, it is important to establish guidelines and recommendations for preventing inadvertent privacy disclosure. In this regard, there could be multiple threat models. So an insider in the company hosting the big data can abuse his or her level of access and violate privacy policies. Uh, and another aspect of this is untrusted partner attack. So if the data is outsourced, or an untrusted partner may be able to sort of abuse their rights, because nowadays a lot of data is outsourced for data analytics, and so people who are not supposed to use a certain piece of data might be able to have access to that piece of data. The next dimension is integrity of and reactive security. So one of the most challenging aspects of big data analytics is the real-time security monitoring, which consists of two angles. So the first one is monitoring the big data infrastructure itself, and the other one is using the same infrastructure for data analytics. So an example of the first one is the monitoring of the performance and health of all the nodes that make up the big data infrastructure. And the example of second is in a healthcare data monitoring environment, monitoring the tools to look for fraudulent claims. So the real-time security monitoring is challenging because of the number of alerts that are potentially may be generated by the security devices. So in this regard, some of the aspects that are important to consider include the security of the Hadoop cluster and security of the public cloud and the security of the monitoring application itself. And another point to note is that there could be an adversarial attack. So someone with access to your data might be able to tamper with the device from which the data is collected, or may tamper with the data collection application running on the device to provide malicious input to a central data collection system. An example of this is medical device security. So this is sort of a very sensitive issue when it comes to healthcare data security applications. So why securing big data framework is difficult? I guess one of the things that we often say is that security is almost an afterthought. When software engineers develop and design a system, they're mainly focused on the functionality aspects of it, the performance, the scalability, and so on. So security is not always considered, or they're not given the due consideration that it demands. And then another aspect is nowadays we have data gathered from different sources, different kind of data formats. There is also real-time data feed, and so we're in a situation that we have something like a data lake, and also there could be issues with automatic replication, as you may, if you're familiar with HDFS. So when you upload a piece of data, it gets replicated to 2 or 3 different locations. So there are more possibilities for security breaches. And also there are different ways to access data that users have different kinds of analytic needs. Um, and cloud always adds on top of this another dimension for potential security issues. So I thought I would sort of mention briefly about some of the important pillars of security that we might be aware of. So the first one is authentication. So this basically is the process of verifying the identity of user. And some of the typical techniques are username and password, public key infrastructure or LDAP. So the main idea is to prevent untrusted users any access to the cluster network. On the other hand, if the network is trusted, then everyone is a good citizen. So basically, we can, if you determine who is a good citizen and who is not, so we should let the good citizen access your network and your data. The next pillar of data security is the authorization. So it is the process that takes place after an authenticated user requests some resources. This is also known as access control. This aspect mainly deals with roles and privileges, and we can consider aspects such as cell-level access control, such as in Accumulo, or access control list, such as in HBase. So Accumulo is quite well known for its cell-level access control mechanism. Basically, it's an atomic key-value pair. Each atomic key-value pair is tagged with an expression that describes the role required to read that entry. And so when every time a new query comes in, a role check is performed. So this actually allows you to do a very fine level access control. The next pillar of data security is data governance. So this aspect enables an organization to ensure that high data quality is maintained throughout the lifecycle of the data. The key focus areas include availability, usability, consistency, data integrity, and data security. So the goal of data governance is to establish processes to ensure effective data management throughout the enterprise, such as restricting access to data, restricting actions that people can take on data, and record users' activities. The final pillars of data security is data protection. So data protection is to protect the data against accidental or intentional losses, destruction, or misuses. Accidental losses could be due to human errors, software or hardware errors. There could be theft or fraud. Loss of privacy or confidentiality could also cause breach of data protection. And loss of availability could be due to denial of service attacks or some kind of sabotage attack. Hadoop provides some level of security through encryption on data in transit, but it does not have native encryption on data at rest. So having seen the different dimensions of data security and different pillars of data security, I'll briefly talk about, so I have about 3-4 minutes. I'll briefly mention the landscape of big data security. This is by no means um, um, a lecture to describe each of them, but I can mention something. So one of them is Apache Knox, that is a centralized authentication service for Hadoop-based applications. Then Apache Ranger is an authorization systems for Hadoop cluster resources. We also have Apache Century, which provides more fine-grained authorization for Hadoop. Apache Atlas and Apache Cloudera, these are Cloudera Navigator are data governance solutions. So this is the feature matrix for these systems. As you can see, the aspects include authentication, authorization, data protection, and auditing and governance, the 4 different pillars that I mentioned. And on the horizontal axis, you have Apache Knox, Ranger, Sentry, Atlas, and Cloudera Navigator. And different systems have different levels of support for these features. So I guess I will just talk about one of them, which is the Apache Century system. The motivation behind this Apache Century was that the existing authorization systems were fragmented, either coarse-grained and or manual. So enterprises increasingly need a centralized authorization component that can work across companies, and it has to be fine-grained and role-based. So Apache Century was developed by Cloudera, and it's a secure layer for Hadoop-based applications such as Hive, Impala, and Solar. It allows administrators to grant, revoke access to servers, databases, tables, views, indexes, and collection. And also in Sentry, you can also set up role-based privileges such as on select, insert, all, update, and query. It supports multi-tenant tenant administration, and you can set up separate policies for different kinds of schema. Now, this is the overall architecture with the different layers in Sentry. So it can work out of the box with different Apache Hive-based systems, Apache-based systems such as Apache Hive, Apache Solar, Impala, and HDFS, which is the underlying distributed um, file system. Suntory is designed to be a pluggable authorization engine for these components. It allows you to define authorization rules to validate a user or application's access requests for Hadoop resources. It is highly modular, so it can support authorization for a wide range of data models in Hadoop. So here we show two specific components, policy engine and policy provider. These are sort of the main aspects, the main modules that can support this authorization feature. So let's take an example of a query issued, let's say, by Bob. So he's submitting this query with Apache Hive. Select star from production.sales, so very simple query. So what will happen is that Hive will identify that user Bob is requesting the select access to the sales table. So at this point, Hive will ask Sentry plugin to validate Bob's access request. So the plugin will retrieve Bob's privileges related to the sales table and check which of these requests is valid. So if the user Bob has is allowed to have access on select, so then this query will be allowed, and the user also needs to have read access to the production.sales table. So this checks are performed by Sentry, and then if everything is fine, then the user is given a go-ahead and the query is executed. Otherwise, if there's insufficient privileges, then the query is not executed and an error message is returned to the user Bob. So in conclusion, security and privacy issues become more exacerbated when it comes to big data systems. And normally, when a system is designed, security does not come as a top priority, but rather an afterthought. Um, and so a big data security framework can address some of these challenges that I mentioned. So some guidelines, I guess it's always good to have some rule of thumb. So always try to segregate duties. There's also a need for segregation of data access. Another important aspect of any system is to document everything. So, and this should be part of the process for a particular company. So document, control, response, um, and planning. And finally, pay attention to technology. So when it comes to security, strong authentication and authorization always are helpful. And finally, and with real-time data streaming, real-time monitoring is becoming more and more important. So systems that can support these features um, will get traction in the industry and the research organization alike. So with that, I conclude my talk, and I'm happy to take any question if you have.